Hello students, in today's video lecture we'll discuss about conic sections. Now these conic sections are part of your engineering drawing or engineering graphics. Engineering drawing, or you can call it as graphics also. Now how you get these conic sections, what are these conic sections, how to draw them, this is going to be our lecture today. Okay. So I'll give you today complete introduction related to conic sections. Okay. Now conic sections are nothing but I'll try to write few types here. For example, number 1 circle, number 2 ellipse, number 3 a parabola, 4 hyperbola, 5 isosceles triangle, and 6th one rectangular hyperbola. Okay, these are different conic sections that we can obtain with the help of a cone, simple cone. If you do some cut sections to that particular cone, we'll just arrive to these solutions. Okay. In this introduction part, we'll see each one of them, how we are going to obtain them is by taking a right regular cone as an example. Okay. We just obtain all these with the help of that particular right regular cone. Okay, that is our introduction part today. Now here the thing is, now for example, if I look at a cone which is placed on a table, flat surfaced table with its circular base resting on the table. Okay, means the axis is completely perpendicular to that particular table. So when I view from the front, I could see this shape. I could see triangle of this kind followed by an axis line when I view from the front, and when I view from the top, I could see a circle. Okay. Let us draw by using a projectile line. If you understand this particular concept properly, then rest of the things become so easy to draw. Let us draw the top view also for your understanding. This is the top view. Okay, I could see the top view from the top, but here our intention is to see how to arrive to solution called circle, ellipse, parabola, hyperbola, all these conditions. Okay, now for example, I call as, let us know the terminology first, this as generator 1. Okay, this as generator 2, and this point we call it as apex, the meeting point of two generator we call it as base on which it is resting. Now for example, this particular cone, right, a regular cone, what you call regular cone, if this particular cone is cutted, for example, horizontal to that particular base, if this is cutted horizontal to the base, if you consider this as the cutting plane, this is the cutting plane, this is going to be your view of the observer. Okay, if I cut horizontally with respect to the base, then what I could see from the top is I could see a smaller circle, something like this. I could see a smaller circle here, which will try to hatch. Okay, the portion which got removed, this is the portion we'll try to remove, the apex portion, and this is the portion which will remain. When I view from the top, I could see the bigger circle followed by a smaller circle. Okay, if you cut the cone, you could see a smaller circle from the top. In the same way, how to arrive to second one. Now we'll see the method of drawing a circle, method of drawing an ellipse, parabola, hyperbola, rectangular hyperbola in the upcoming lectures. Now in this part of video lecture, we'll try to see the introduction part, how we are going to arrive to this particular solution, what is happening behind. Okay, so this is how we'll arrive to a circle. Then again ellipse, to get an ellipse, how to cut this particular right regular cone. To cut this, now for example, there is a cutting plane which is cutting the right regular cone in this way, for example, with some inclination, cutting both the generators with some inclination. This is the case, this is the position of the observer. If this is the case, then I could see an elliptical section from the top, elliptical completely. Okay. So if you view from normally, you could see that ellipse shape. Initially, let us consider this section as first one, circle section as A. Circles, if circle section is AA, then you could see circle when I view from the normal, means from the top. When I view from the top, I could see a smaller circle. Let us consider this as BB section BB, cutting plane BB. Okay. If that cutting plane is B, I'll consider this. Then I could see an ellipse, elliptical cross section, but the position of the observer should be normal to that particular cutting plane. To this particular cutting plane, the position of the observer should be 90 degrees. Then only you could see that ellipse. Similarly, now second we justify this. Now B dash B hyphen B represents cutting plane ellipse. Okay. AA represents cutting plane circle. Fine. In a similar fashion, for example, if you want to arrive to a solution called parabola. Now we have seen if a right circular regular cone got cutted with some inclination passing through both the generators, but it is not at all cutting the base. When it crossed to both the generators, we could see an ellipse. In a similar fashion, a parabola. Whenever a cutting plane is passes through one of the generator, parallel to one of the generator. For example, if I take this as the generator, I'll draw a cutting plane parallel to that particular generator, exactly parallel to that particular generator. Okay. Then I could see a conic section called parabola. Let us consider this as C. If the section is C, then you could see parabola of this kind, a curve of this kind. Because you could see this curve, because it is not connecting, it is starting at this point, ending somewhere. It is not at all traveling 360 degrees, because here you could see this particular section C is cutting the base. When it cuts the base, there won't be any continuity. Have a now, like physically you need to feel that there is a 3D component, okay, which got cutted in different positions to get this conic sections. Okay, if this is the case, now here in both the cases, in case of circle and ellipse, the cutting plane is not at all cutting the base, whereas in case of parabola, it is cutting the base also. The cutting plane is parallel to one of the generator and it is passing through the base. If that is the case, you could see a section of this kind. So this is also justified, parabola. Now hyperbola. Now to arrive to this particular hyperbola, again same thing need to be followed. The thing is, the section plane should pass through the base. Section plane should pass through the base, it should cut the base, it should maintain some inclination, but it should not be parallel to any of the generator. That is the only difference. There should be some inclination with respect to this particular generator. It should maintain some inclination and it should pass through the base and the one of the generator. Base and one of the generator. Fine. Something like this. For example, it is passing through the base, a cutting plane, and it is cutting the generator. It is traveling in this way. This is how you do. Now this, let us name this as D-D. If the section is D, now you are going to get a hyperbola of this kind. Bit wider curves you will get. Okay. Now here you could see the difference. Ellipse. Now these two curves joined and meet at same point again where it got started, and where it coming to parabola, you got a section, C kind of section. In case of hyperbola, the two curves are wider, bit wider comparatively. Similarly, in case of isosceles triangle, the cutting plane should pass through the base as well as it should pass through the apex point. In case of isosceles, it should pass through apex point. That is more important. Now only difference is the section plane should maintain some inclination, followed by it should pass through the apex point, this particular apex point. If this is the case, then let us call this as E. You'll get an isosceles triangle if it passed through the center. Now coming to your academics, we are going to deal with ellipse, parabola, hyperbola. These three are very much important. Maybe a rectangular hyperbola also. Fine. So in case of isosceles triangle, the cutting plane should pass through the base with some inclination and it should touch the apex point. It should touch the apex point, so that you will get an isosceles triangle. Similarly, to get this particular rectangular hyperbola, the cutting plane should be parallel to the axis. Cutting plane should be parallel to the axis at some offset distance. Okay. For example, maybe at this particular point, I'll take a different color to make you understand better. Maybe at this particular point, parallel to the axis, I'll try to draw a cutting plane. This is a view of an observer. Okay. If this is the case, let us name this as, now it should pass through parallel to that particular axis line. This is how you'll do. Now in general, to have a better visual effect, what I try to do is, I'll try to draw 3D cone. The 3D cone will look something like this, followed by, and there will be an axis line through the center. This is how we'll see. Now for example, if the same cone got cutted, if it is a parabola, for example, if it is a parabola, then the cone shape going to be something like this, maybe followed by a curve and a straight line. If you remove a slice with the help of a cutting plane, then you could see a shape of this kind. Or similarly for other things also. Okay. This is a circle, ellipse, parabola, hyperbola. These are very much, ellipse, parabola, hyperbola are very much important when it comes to conic sections. There is a compulsory question for your mid as well as for the external. This is about conic sections introduction. We have seen this thing also. Only thing is we need to remember one thing. If I cut this particular regular cone in different positions with some inclinations, these are the different kind of conic sections you are going to see. This is more important topic. And if you talk about plane curves related to this conic sections, plane curves, we are going to, now this is broadly classified into three types. Number one is conic sections. Number two is cylindrical curves, you can call it as cylindrical curves. And number three, involutes. Now we call these three varieties or methods as plane curves. Now we are going to discuss all these types also in the upcoming lectures. Conic sections, nothing but the sections whatever we have discussed, and cylindrical curves, and also the involutes. These are very much important when it comes to engineering drawing basics before moving on to projections. Okay. This is all about the introduction related to conic sections. If you have any queries, you can comment, and thank you for now.